In this lesson, we're going to learn a very important topic in mathematics, which is actually very simple if we explain it in plain and simple terms. That is integration. We can think of integration as a collection of continuous effects where one variable is continuously affecting another. What we want to calculate is the total of these continuous effects over a certain period of time, or let's say the accumulation of effects over a certain period of time. So we can say that integration is simply the area under the curve. For example, let's consider speed and distance. We know that the speed determines the distance covered. So if we have an object moving at a certain speed and we know the details of its speed, we can calculate its effect on the distance, meaning how far it traveled exactly. Let's take an example. If we have a car starting from point 0 and it's moving at a constant speed of 120 for 5 hours, how far would it have traveled after 5 hours? We can calculate it quickly by saying 120 times 5, which is 600 kilometers. And here we can use integration. This brings us to the second mathematical definition of integration. It is the area under the curve. What is this area under the curve? It's simply a rectangle here. So we can multiply 120 by 5, which gives us 600. So we can simply calculate the area of the rectangle, which is 120 by 5, which gives 600 again. Now, if the car kept driving for 6 or 7 hours, we notice that we can derive an equation 120 times x, and this is exactly what integration is in simple terms. Let's quickly recap what we have said. We have said that integration is a collection of continuous accumulations over a certain period. In this case, we used an example of speed and distance. To perform integration, we need to know the details of the influencing factor, in this case the speed, at every point in time. Or to put it in mathematical terms, we need to know the function that describes the influencing factor, which is here is the speed. So we can call it f of x equals 120, which is a constant. So when we know all the details of the influencing factor at every point in time, and we want to calculate the total continuous accumulations over a certain period, integration should come into our minds. We also notice that the integration of the function 120 is equal to 120x plus c. And we will see more about this later. Now we have seen how we transitioned from a simple everyday language to mathematical terms, and it's always important to understand concepts in their plain and simple form first.